Okay, so welcome to part two of the Between Participants Factorial ANOVA screencast. In a little gap that I've had between the part one and part two, I started getting all nostalgic about albums, because it kind of reminded me that it's kind of part one, part two. It's a bit like in the old days when you have to actually get up and turn your record over. So this is side two, probably the less popular side of the album, the difficult bit. So where we were before, strongly encouraging you, the first thing you should do, don't look at the ANOVAs, don't look at the output. That kind of encourages a kind of weird dependency on what the computer's telling you. Okay, is it significant? Is it not significant? And it's very easy to kind of just write down significant, not significant, without really any understanding of what the heck's going on. So really, I think it's incredibly important, particularly when we get to slightly more complex designs, that you look at graphs. That's what we've been doing, and we can see, just to reiterate here, just to summarize what we've talked about, is that this seems to be what's called an interaction. It doesn't seem to be the case that one therapy is better than another, because, you know, PCT is good for males, sorry, is good for females, bad for males. CBT is good for males, but less good for females. And there doesn't seem to be any overall sex differences. It doesn't, on the face of it, appear that females are getting better quickly than males. What it is an interaction, and these are incredibly common, but can confuse people a little bit. Interactions occur all the time throughout, you know, the world, and this is an example of one. There isn't a best way of doing therapy. What it depends upon is who you are, and that's pretty much the case for everything, isn't it? I mean, if you think about, is there a best car? Well, there isn't necessarily a best car in the world. What matters is the match between the particular kind of car and your needs. So for some people, a very large SUV might fit their needs and is the best car in the world. For some people, a sports car fits their needs, and that's the best car in the world. So there's not necessarily a main effect of carness, if you like, that one car is better than another. It's an interaction. It depends upon the match between, in this case, the therapy and the gender of the person. Now, let's not run away with this and suddenly pretend that this is something exciting and interesting. I very much suspect that these data have been made up for demonstration purposes. So let's not take this as a rule of the world. It's more of an example. So we have an interaction going on there, and both of these graphs show in different ways the interaction. This one shows the relationship between PCT, CBT, and sex. So this breaks it down in terms of sex. This one breaks it down in terms of the effectiveness of the therapy. So it's a very similar kind of thing, that for CBT, it's not very good if you're female, it's very good if you're a male, and the opposite for that. Okay, so we've looked at the graphs, and I strongly suggest when you get to the graphs, first thing you do is talk to yourself out loud, like I'm doing here. What's happening? Try and step me through what's happening. Try and summarize it. Try and summarize the main finding of this. There's maybe quite a bit of stuff going on here, but something we can summarize that is the effectiveness of a therapy depends upon sex, such that if you're a male, CBT is better than PCT. If you're a female, PCT is better than CBT. Try and tell yourself what the headline is, and I think that's a really good way. And then when you get to the ANOVA, you're kind of prepared. You know what you might be expecting, and what you predict here is that maybe we've got no overall main effect of therapy, no overall main effect of sex, but a significant interaction. This particular kind of interaction here is a very dramatic one, which is called a crossover interaction, where the actual things cross over. This is about as extreme as it gets. There are other forms of interaction where maybe one of the two lines diverge from each other, like in, say, a kind of like a V-shaped line on its side, which is a much more subtle interaction, but nonetheless can still be significant and interesting. This is just a particularly dramatic one. So let's go right up to the top and have a look at the analysis of variance here. Well, these are just the numbers of participants, not particularly interesting. 20 per group, so not terribly interesting there. So 80 participants overall. These are the means for the females and males. This shows exactly what's on the graph. We can see that CBT takes a bit longer than PCT for females, whereas for males it's the opposite. Okay, so you might want to wish to report that. Probably would want to report that in a table or something. The means and standard deviations. Right, this is our test to test the variances of the different conditions are approximately the same. This is the same kind of thing that you've seen in t-tests. And what this shows here is that the variances is significant here, which suggests that we probably shouldn't be doing the ANOVA we're doing in an uncorrected way. I'm going to skip over that for a moment. We'll pretend, as so often the case, that is non-significant. There are things that you can do with this in order to correct for that, but I'll deal with that at a later date. So let's just ignore that for the moment. Purposes of this, we're just trying to look at ANOVA, not how to correct it. So we'll look at those later. Right, here's the ANOVA table. Now, the important things to look at here in terms of what's going on, first of all, this is the main effect of gender. So if we ignore therapy type, are males getting better quicker than females, or are females getting better quicker than males? Well, the answer is no. There's no reliable difference between males and females overall, which is kind of what we saw in the graph. Yeah, not surprised there. So that's non-significant. There's no effective therapy, so it's not the case that CBT is better or worse than PCT or vice versa. There's no difference there. But there is, as we predicted, a significant interaction. And I really like this way of doing things. Look at the graph and try and see if the ANOVA backs up what your eyeballs are telling you rather than the other way around. Because the other way around, if you've entered the data incorrectly, you've done the analysis wrong, you'll know at this point because you've already seen the graph, and if suddenly you've got a non-significant interaction and a main effective therapy, maybe you entered the data wrong in ANOVA. So get a graph first. So we find there's a significant interaction there. So we report non-significant main effects, non-significant main effects. We report those. You'd report the significant interaction. The next step, as you may remember, is we need to look where these differences lie. So we need to do 4 paired t-tests to see whether where the differences lie between these two. It actually looks like a lot of these are going to be significant. So we would imagine that for males, for example, so that's males, a green line, we would imagine that there'd be a significant difference between cognitive therapy and person-centered therapy for males. We imagine that would be significant. We imagine that there'd be a significant difference between PCT for females, between PCT and cognitive therapy. And we would imagine that there would be differences if we hold therapy constant. That would be some sex differences depending on which therapy they have. So what we need to do now is to do the horrible file splitting thing. So we go to data and we go to split file, and I've probably left these things in here. No, I haven't. So what we need to do, first of all, what we want to do is what do we want to hold constant first? Okay, let's test for therapy. If we're going to test for therapy, again, holding gender constant, then we need to compare groups, put gender in there. So now we can test for therapy for each of the individual sexes. So is therapy significant for males? Is therapy significant for females? So we split the file by gender so we can test for therapy. We go to analyze and we simply want independent samples t-tests. There. Now we've already split by gender, so we want to put therapy as our grouping variable, and there are 2 levels, 1 and 2. And then we want to put hours as our test variable, just like that. There's no interesting options in t-tests. Okay, this is where it can be a bit horrible. Right, so the top part here, which is group statistics, this is just the means of the 2 differences. And you need to look at this in order to interpret this stuff below. Because interpreting this stuff below becomes quite difficult if you haven't got your head around what's going on here. So what we're saying here is that gender, so for females, this is the top line here, look at the number of session hours. Well, females have taken 28 hours of sessions on average, 28.4, compared to 18 for PCT. So that looks significant, doesn't it? So we'll check that. And then this is the same thing for males. So for females, is cognitive behavioural therapy better than PCT? And for males is, PCT better than cognitive therapy. For males is cognitive better than PCT. The answer is yes. Now Levine's test is not significant, so we can ignore that and read across the top lines. We can assume equal variances, and quite clearly there's a very significant difference here. T 4.8, degrees in freedom 18, with a very large significant, and for this one we write P is less than 0.001. If you want to know how big that number is, you can actually click on it Not to get too. That shows you how small that number is. It's 0.0001. So that's kind of like 1 in 10,000, less than a 1 in 10,000 chance, or slightly over 1 in 10,000 chance of that being a random effect. So a really small number. And this one probably is going to be even bigger. That one, don't even look at that. That's gone into the exponentials. That's such a small number. It looks like it might well have sort of 12 decimal places or something before. Anyway, let's not scare ourselves too much. Let's just report it as p is less than 0.001, which is less than 1 in 1,000. So both of those significant. So the next step we need to do is to do it the other way around. So let's go back to split the file. If we now take gender out and put therapy in, there we go. And then we can now create groups based on therapy. And then we can go back to our t-tests, compare means, and we do independent samples t-tests. We want to take therapy out and put gender in. And again, we've got 1 and 2. That's okay. And there we go again. So for holding cognitive therapy constant, are females doing better than males? Well, they certainly seem to be. For PCT, males are doing better, taking longer, than females that are doing worse. This big is bad is sometimes quite a tricky one to get your head around when a big number is worse, because usually we're used to thinking about big numbers as being good things. And again, these differences are very significant here. T of 11, T of -4. And we'd simply write up all of those tests. So in terms of what we're doing here, in terms of writing it up, we'd say we put the means and standard deviations either in a table, probably. We could do it in text, say the mean for the male standard, but I think probably a table when you've got more than 2 variables to compare. More than 1 variable, more than 2 levels of a variable. I think you start to increasingly want a table. The more numbers you've got, the more useful a table is. Maybe you want to put a plot in there, because that plot does nicely show the interaction. So you would put the raw data in there, seeing it says there was no overall main effect of sex, report the ANOVA. There was no overall main effect of therapy type. There was, however, a significant interaction. Again, report that. And obviously report all 3 ANOVAs, the 2 non-significant ones and the significant one. And then you would say you did pairwise comparisons. And that's what we did. We did t-tests, analysing the simple effects, breaking it down by just looking at the data points, breaking it down by sex, breaking it down by therapy type. They're the simple main effects. What I forgot to say there is that we would also need to do a Bonferroni correction, which our usual level of significance is 0.05. We need to divide that by the number of pairwise comparisons we're doing, which was 4. We did 4 t-tests. So that gives us our new significance level of 0.01. So anything less than 0.0125 is significant. Okay, so that's our Bonferroni correction. So we need to report that as our new threshold for whether something isn't significant. As we saw, those t-tests were so significant. They were the t values were much smaller than this. So that's basically ANOVA, the between participants ANOVA. One thing I will show you is to get a nice graph. While I've got a few minutes left on the screencaster, if you want to get a nice graph, because those graphs, those plots that ANOVA produces are very helpful in interpreting what's going on, particularly the line diagrams. Very good. They don't look quite so nice if you putting it in a report, look a bit kind of flaky. So if you want to do that, you get a graph. Let's do a bar chart. Legacy docs, go under graphs, legacy docs, and we want a bar chart. Now this gets a bit tricky when you've got a between participants design like we have here, and we've got more than 1 independent variable like we have here. Then you want to go clustered like that. There, clustered because we've got more than 1 IV, and we want summaries for groups of cases clicked. If it's a within participants design, then you would click simple, as we'll see when we do that, and summaries of separate variables. It's all a little bit like witchcraft, this, and unfortunately you just got to remember it, or do what I do and just kind of randomly click buttons until you eventually get something which looks like a graph. So we go define, and I've already got these in here, but let's reset so we can do it again. Our bars represent, they're our session hours. So number of cases, but we want mean.